All right, let's talk about one of the trickiest parts of learning C, strings. We're going to use 6 key code examples to really break down how they work from the ground up.
So, let's kick things off with a little puzzle, one that pretty much unlocks everything you need to know about this topic. Just keep this question in the back of your mind as we go.
Okay, let's get right into it. To really get a handle on this, we first need to understand what a C string is, under the hood.
Let's build our first string together and uncover its secret ingredient. Okay, check this out. This is pretty much the simplest C string you can make. We just declare a character array called greeting and give it the value hello. But here's a fun little fact that might surprise you. Hello has 5 letters, right? H-E-L-L-O. So why on earth is C telling us the size is 6? Where is that extra character hiding? Well, that secret ingredient is what I like to call the invisible stop sign. You see, behind the scenes, C automatically tacks on this special character at the end of every single string. It's called the Null Terminator, and you write it as \0. Think of it literally as a stop sign. It's how functions like printf know, okay, stop here. This is the end of the string. Anything after that is just random junk in memory. So here's the big takeaway. A C string is always 1 character longer than it looks. And this really hammers home the point that a C string is nothing more than an array of characters. Because it's an array, we can grab any of its individual pieces just by using its index. So word at index 0 gives us the H, and word at index 1 gives us the I. It's just a simple sequence of characters, one after the other, with that all-important stop sign at the end.
String in C isn't some kind of magical, complex thing. Nope. It's really just an array, a list of characters, all stored one after another in memory. That's it. And this is a perfect example of what I mean. Since it's an array, you can just grab any character you want by its index. So word at index 0 gives you the C, word at index 1 gives you the hyphen, and so on. This is absolutely fundamental.
And here's a super common thing you'll see all the time, looping through a string. You're basically just walking through that array, character by character, and doing something with each one.
Okay, so now that we know what a string really is, let's talk about all the cool stuff we can do with them. This new understanding unlocks some really powerful ways to play around with your text.
This is probably the first thing you ever did with a string, right? Just declaring it and printing it out. Super simple. You give it some text, and the compiler handles all the details, including tucking away that secret null terminator at the end for you.
And check this out. Printf is pretty smart. You can give it multiple strings, and it just works. It prints the first one, sees that null terminator, stops, and then moves right on to the next one. It's a really efficient way to build your output. Now, this is a really important point about C strings. They're mutable. It's a fancy word, but all it means is that you can change them after they've been created. Since it's just an array, we can go right into index 0 and swap out that B for a W. And just like that, bird becomes word.
All right, let's put this into practice with something we do all the time, getting input from a user.
Okay, so you use scanf. Seems simple enough. You make some space for a name, you ask the user to type it in, and scanf puts it in the right spot. And hey, if they type Alex, it works perfectly. But, and this is a big but, this is where so many people fall into a classic C trap.
Seriously, if you've ever tried to get a full name from someone like John Doe and your program just completely freaked out or did something weird, this is almost certainly why.
So here's the problem. You ask for John Doe, but your program only gets John. Why? Because to scanf, that space is basically a stop sign. It hits that first bit of white space and just stops reading. It completely ignores Doe. So how do we get out of this trap? Well, here's the pro move. You use a function called fgets instead. Just look at the difference here. Scanf fails miserably, but fgets, it grabs the whole line, John Doe, spaces and all. Perfect.
So the big takeaway here is this. When you need to read a whole line from a user, fgets is the right tool for the job. Period. But you know what? It's not just about getting spaces right. It's also way, way safer. See, with fgets, you have to tell it how much space you have. This one little thing prevents a massive security problem called a buffer overflow, which can crash your app or even worse, open it up to attacks.
So, you just learned about the scanf trap. Mastering C is really all about learning these kinds of invisible rules. It's like a puzzle. From the null terminator to how input functions really work, you're slowly decoding the language.